Good evening to one and all. This is Hasini from Group 170 here to discuss about the second phase of the project AI-based plant disease detection system. In the first phase, we have discussed how the technology impacts the agriculture and the possible benefits from it. In the second phase, we are going to see the technical aspects and the process and the steps involved in making such a system. Coming to the main components of the solution, there are five main components such as the AI model, data collection module, user interface, API layer, and the database. Coming to the AI model, the AI model of this project is the CNN model. The CNN model receives the plant disease datasets from the Calvin and it produces the output diseases. And the data collection module, it manages and stores the input images which are from the user devices or the sensor field placed in the fields. And the user interface. The user interface actually allows us to communicate with the users, such as uploading images, viewing diagnostic, receiving recommendations, and checking the history. The API layer. API layer is the communicator between the front-end application, the database, and the AI model, which is the CNN model in this case. In the database, as the name suggests, it is used to store user data, plant images, diagnosis history, and the usual tracking history. Further delving into the main components of the system, we have the front-end part, which is used to develop the user interface where the applicants can upload the image for the disease prediction. It is built through modern web technologies such as HTML, CSS, JavaScript, and React.js. It provides an intuitive experience for the users to interact with the system. And then we have the backend API, which is a hybrid of Express.js and Node.js and Python frameworks such as Flask, and Fast API. It acts as a pathway for the communication. It handles request, image preprocessing, and the result transmission. In a way, it is the central nervous system of the application. And then we have the Hugging Face CNN model. The CNN model is trained to receive pre-processed images, perform disease prediction, and send the output back to the API layer. The CNN model is hosted on the Hugging Face Model Hub. The model is either deployed on the cloud platforms such as AWS or Google Cloud, or is either run locally. And then we have the database. Database stores the user input, model predictions, and the feedback for the continuous learning and the improvement. The database is a hybrid of PostgreSQL, which is for the unstructured data, and the MongoDB, which is used for the structured data. Coming to the underlying data structures, we have quite a few of underlying data structures, but let us focus on the primary ones. Image data structure. It stores the image data in executable formats such as JPG and PNG files along with the metadata of the datasets. And then there is the user profile structure, which contains the user details such as interaction history and the account status. And then we have the diagnosis data structure, which contains the plant type, plant disease type, confidence score, and the recommended treatments for the diseases and for the spreading. And then we have the model input and output structure, which includes the features such as meta image data and the model predictions. Coming to the tech stack, we have the front-end technologies which utilize the HTML, CSS, and JavaScript frameworks like React or Vue.js for building user interfaces. In the backend technology, implement Node.js and Python frameworks such as Flask or Fast API for server-side logic. And then we have the database, which is a hybrid approach of PostgreSQL for structured data and MongoDB for unstructured data. And the Hugging Face integration. The CNN model is hosted on Hugging Face so that it can use the Inference API to deploy the CNN model, allowing easy access via RESTful calls. And then there's the deployment. The deployment uses Hugging Face Inference API to deploy the CNN model, allowing easy access via RESTful calls. Coming to the different roles in the application, there are different roles such as user, admin, data scientist, and developer. User is a person who actually uploads the plant images and receives the plant disease as the output. Admin is someone who actually oversees everything such as managing data sets, overseeing model training, and monitoring the system performance. Data scientist is someone who prepares and updates the model for data disease detection according to the current trends in the agricultural world. Developer is someone who oversees the technical aspect like maintaining and developing features, handling integration, and fixing bugs. Talking about the interfaces developed, there are quite a few interfaces developed throughout the whole system, but let us focus on the important ones such as the user interface, which is the input screen of the users, allowing easy access and usability. And the model API interface. It is an interface developed for the API calls. The REST API is used to communicate with the AI model for the disease prediction. Data pre-processing interface is used for filtering and adjusting the input data before the model inference. And the feedback inference allows users to give feedback on diagnostic accuracy, further improving the quality of the website. And the admin dashboard is for the admins for managing the system functions, user logs, and model performance, overseeing the development of the website. Now that we have talked about the front end and back end parts, let us focus on the datasets and the processing. There are five major steps included in the datasets and the processing. The first step would be the obtaining the datasets from the Kaggle, an image dataset of various plant and annotations for plant different diseases, potentially sourced from the Kaggle datasets or other agri-tech resources. The second step would be data processing overview, which includes the overall process of preparing the dataset for analysis, which includes the several key steps. And the third step would be the image pre-processing, which includes techniques such as resizing, normalizing, and enhancing the quality to ensure image compatibility with the model. The fourth step would be the data augmentation. This data augmentation contains methods such as rotations, zooms, and flips and are applied to increase the diversity of the training data. And the fifth step would be the data storage. It is basically done by the MongoDB. MongoDB is utilized to store each user's diagnostic history along with the links to images and the prediction of the metadata. Coming to the workflow of the system, the workflow is as listed below. The first step is the user login. It is done by a secure authentication system with options for social login or email-based accounts, ensuring user data privacy and providing a personalized experience. The second step is for the user to upload an image so that he can receive the planned disease detection. And when the backend processes the image, it sends an API call to the CNN model. The CNN model receives the pre-processed information and it provides an output to the API layer. When the API layer receives an output, it displays the output onto the result screen of the system application. And when the output is displayed, user can receive the notifications and the recommendation, which can be used as a treatment tips. The additional workflow would also include the feedback collection, in which user the rate accuracy, which is logged in for quality improvement. Then there is also the save history option in which the user history is saved in the database for the future reference. Coming to the business logic of the system, there are three essential components such as the image validation, prediction thresholding, and the feedback loop. The image validation implements a robust check for image clarity, size, and format to ensure that only high quality inputs are processed. This includes the automated detection of a blurry or improperly formatted images, along with the user feedback for improvement. The second one would be the prediction thresholding, which applies a dynamic confidence threshold based on the disease type and historical accuracy. This ensures that the only reliable predictions are presented to the user with lower confidence results flagged for an expert review. The third one would be the feedback loop, which integrates a comprehensive user feedback system, allowing for correction of misclassification and submission of additional information. This data is crucial for continuous model improvement and adaptation to new or evolving plant diseases. Coming to the sources of information, this project has various sources of information, but let us discuss about the important three. The first one would be the Kaggle plant disease datasets, which are a source for the model training datasets and disease characteristics. The second one would be the technical documentation, which includes TensorFlow guides, AWS best practices, and optimal implementation of AI models and the cloud infrastructure such as AWS. The third one would be the deep learning and MERN stack development, which is provided by the college seeking guidance from deep learning tutorials and the Monstack development. These are the major three sources of information which are used to develop this project. Thank you.